So this is 5th period. We'll start on number 3 and do 3, 6, 9. If you need some of the other problems, look at the other videos. Number 3. K is between 0 and pi over 2. And the area under the curve, y equals cosine x, from k to x equals pi over 2 is 0.1. Then k equals. Oh, this is... Okay, so cosine of x looks like that. That's pi over 2, and k is less than pi over 2. So we don't have to worry about, some positive area, some negative area. We're that area between 0 and k. And it tells me that area is 0.1. So the area is the integral from 0 to k cosine of x dx. Oh, and that's equal to 0.1. So it's a calculator question, but you still have to integrate by hand because of the way they set this problem up. So what's the antiderivative of cosine? Sine of x, but is it positive or negative? It's positive, yeah, because the derivative of sine is cosine. So sine of x from 0 to k is equal to 0.1. So that means sine of k minus sine of 0 is equal to 0.1. Sine of 0 is 0. So the sine of k is equal to 0.1. Okay, so how do I sync equals 0.1? So how do I undo a sine? Inverse. So I need to do inverse sine of 0.1 and hope that answer choice is there somewhere. It is not. So what did I do wrong? Mode in radians. The area under the curve, y equals cosine of x. Oh, maybe I should read the problem more carefully. What's wrong? What did I do wrong here? I set the limits wrong. It very clearly says from x to pi over 2. So k to pi over 2. K to pi over 2. So sine of pi over 2 minus sine of k equals 0.1. Yeah, I set the limits wrong. Sine of pi over 2 is 1, although you have a calculator, so you could do that if you needed to. So if I subtract the 1 over, negative sine of k is equal to negative 0.9. So sine of k is equal to 0.9. So now back to the inverse sine of 0.9 instead. 1.120. Yes. All right, you got to read the questions carefully. That's a good example of if we want you to do an antiderivative by hand, but it's a calculator test, we can do it. We can make it, force you into that. Number 6. Let S be the region enclosed by the graphs of y equals 2x and 2x squared from 0 to 1. All right, I think, and I can certainly look at a graph to make sure, but that's what the graph looks like, although you have a calculator, so if you didn't know that, you could still graph it and find out. There's the line, whoops, and there's the parabola. Okay, so the line is the top one. That probably is what we're getting at here. Where's the volume of S when revolved around the line y equals 3? so this is going to be an outside radius and an inside radius problem. All of them are dx. And they intersect at 1. So we'll go from 0 to 1. Up, they're all 0 to 1. Big R squared minus little r squared. So yeah, the only difference here is who's big R and who's little r. So big R would be top minus bottom. So that's 3, it's the top one. The bottom one is the curve, so that's 2x squared. Little r, still thinking top minus bottom. The top is 3. The bottom is this line, but that's 2x. So big R squared would be 3 minus 2x squared all squared. Little r squared is 3 minus 2x squared. Okay, so it's 3 minus 2x squared squared, 3 minus 2x all squared. So I think it's A. So probably didn't need a calculator for that one, but if you did, you could graph it and make sure you knew who was top and who was bottom.
Wait, again, how do we find out who's top and who's bottom?
I would say look at the graph. And I can tell by looking, like the straight line is the top one and the parabola is the bottom one.
Oh, yeah, I see that.
Number 9. Let M be the region in the first quadrant, bounded above by the graph of y equals 3x, and below by the graph of y equals x squared. Uh-oh, I don't think I'm doing this. Here we go. So bounded above by 3x. Again, you got a calculator, so if you need it, use it. And below by x squared. So 1, 1, 2, 4, 3, 9. So very similar to that region we were just looking at in number 6. Above by 3x, below by x squared. Uh-oh, all my answer choices are dy, so this is going to be fun. Which of the following gives the volume of the solid revolved around the vertical line x equals -3? So I'm going to come all the way over here to x equals -3. Revolve it around that. So definitely a dy problem because we're revolving this way. If you wanted to sketch it, that donut looking thing, or that's another onion ring, I guess. So let's see, outer radius. Well, let's back up all the way to the beginning. This is washers. Washers dy. So dy means I need to go 0 to 9. They all have 0 to 9. R squared minus r squared. I wrote them spread out like that because I know they're going to be big expressions for r. Let's see. Big R would be to the outer edge. Big R is to the outer edge. And I'm not doing top minus bottom. It's a left and right thing, so I've got to go the right side minus the left side. So the right side is this curve, which I would normally call x squared, but I can't call it x squared because I have to be in terms of y. So what should I call this curve? Square root of y. So square root of y minus, and then this curve is negative 3, but so square root of y plus 3. It's a washer because there's a hole in it. There's a hole in it because the axis of rotation was not completely touching the area. If the axis of rotation is up against the area the whole way, then that's a disk. There wouldn't be any holes when you rotate. But here you've got all this.
X equals 0, that would be a disk.
At x equals 0, it'd still be a washer. The only way to make this one a disk would be something we don't know how to do, and that would be to like rotate it around this slanted line. Yeah, that would be crazy. We're not doing that. Okay, so big R then is square root of y plus 3 all squared. I wonder if that narrows it down enough. That looks like D. Let's make sure, just to make sure little r matches up. So there's little r from axis to inside edge. Right minus left. I would normally call that y equals x, but now I'm going to call it x equals y. Y plus 3. Oh, what happened here? Why is that not right? Oh, that's 3x. So y over 3 plus 3. So yes, it is D. Another example of a question that's with calculator, but you don't really need your calculator unless you wanted to graph those in the calculator to make sure you knew what you were looking at. Number 12. Okay, now we hit the free response questions. By the way, just looking at the time, there's 2 free response questions I want to do. They're supposed to take 15 minutes each. We have 30 minutes left, so I should have time to do both of these. We'll see if that's the case. A tank has a height of 10 feet. The area of the horizontal cross-section of the tank, h feet, at h feet, is given by the function a, where a is measured in square feet. Function a is continuous and decreases as h increases. Selected values of a are given in the table below. So the higher we get, the less the area is. So we don't really know the shape of this tank. There's really no reason to assume it's even circular. But as we go up, so at the bottom, a is 50.3, and at the top, a is 2.9. And we know some other values in between there. So I'm trying to just get a feel for what's going on here. Use a left Riemann sum with 3 subintervals to approximate the volume of the tank. Well, the volume of the tank is going to be area times height. So let's do the area times the height 3 times. And it's a left Riemann sum. So we'll make sure we use the left values. So the first area is 50.3 and the height is 2. And the next segment, I guess, is area of 14.4 and a height of 3, 2 to 5. And the next area is using 6.5 for the area and a height of 5. Uh-oh. Yeah, 5 minus 2 is the 3. So what's sort of going on here is we know the area at the bottom is 50.3. So we're just going to assume the area of that whole chunk is 50.3. And then we know this next area, this little circle, is 14.4. So we're going to assume that whole chunk is 14.4. And then the next one's 6.5, and so we're going to assume that. So I can tell already this is going to be an overestimate, because we keep using the big values in case they ask that. Calculator active, so I guess it wants me to give an answer. 50.3. Although I need to check and ask if that's still a safe stop. It's like you have a calculator, so there's no reason to not, but I guess you could still make, mess up typing something in your calculator, like I almost did. So 176.3. Overestimate or underestimate? Well, my picture shows overestimate, but picture isn't a good enough reason. So what's my reason? Oh, it did say indicate units of measure, which means there's a point attached to that. If we did feet times square feet, feet cubed. Okay, overestimate. We did a left sum of a decreasing function. And that's my reason. This looks weird like this. It might have been easier to think of it like this. 50, 14, 6, and 2. And we kept doing a left-hand sum, so we know we're outside of we don't know what the real curve looks like, but whatever it looks like, we're definitely above it.
Left decreasing and right increasing are both overestimates or right?
Let's see, if you switched both of those, so left decreasing and right increasing would be an over, yes.
Okay.
And if you just switched one of them, then it would be the other way around.
So mismatched, then it's an underestimate.
Yeah.
Okay.
Yeah.
Gotcha.
And you can memorize that, because once you memorize one of them, like they all kind of fit together.
Gotcha.
I don't really memorize them because I can just draw the picture and figure it out. But you're right. Left decreasing would always be an over. So that means a right increasing would be an over. And a left increasing and a right decreasing, those would be under. That's what you said. But I don't want to remember that. I just want to think about it each time. Part C. The area in square feet of the horizontal cross-section at height h is modeled by the function f of h equals that ugly thing. Based on this model, find the volume of the tank. So we're still going to do kind of the same thing, area times height, but that area, because I know the area at each individual little slice all the way up, I can add them all up, dh. So my thicknesses, instead of this clunky, chunky looking thing I drew up here, like now we know what this thing looks like, so now we can get an exact volume. And I think this is all I would have to... Nope, that's not quite enough to show, because I put A in there when I probably should have said f of h. Oh, don't want to type all that in. I think so. Although, am I going to have to use that again? Using the model from part C? Alright, I'm going to type it in for Y, because it seems like I might need to use it again. 50.3 over e to the 0.2x plus x. It's a weird looking function. I suppose I could graph it, but I really don't even want to. Okay, so now I can just do y1. .325 units of measure. It's volume and everything's in feet, so it's got to be feet cubed. I assume they want you to think about feet squared times feet, but you don't even have to do that. Like, the volume's got to be feet cubed. Water is pumped into the tank. Oh, by the way, just kind of a side note. We got the exact volume to be 101. We got our overestimate to be 176. So those two ideas kind of fit together. Water is pumped into the tank. When the height of the water is 5 feet, so when h equals 5, the height is increasing at a rate of 0.26 feet per minute. So what is that in terms of variables? Feet per minute, increasing at a rate. So it's d something dt. It's got to be dh dt because the height is increasing, and the units would suggest height rather than volume. So dh dt is 0.26 feet per minute. Okay, so we're pouring water in. H is increasing. That makes sense because we're pouring water in. Using the model from part C, find the rate at which the volume of the water is changing with respect to time when the water is 5 feet. So we want to find dV dt. Find dV dt. Well, we know that V is 0 to 10 f of h dh and we want dV dt out of there. Well, I guess I need to take a derivative of both sides. That'll definitely get me dV dt on the left. It'll get me a kind of a mess on the right. So dV dt equals, I want to take the derivative of wait a minute, I'm not going 0 to 10. That would be the whole volume. I think I want to put like 0 to h right there. That way it's changing. That volume is changing as we go up. So I've got the derivative of an antiderivative. What do I do with the derivative of an antiderivative? They kind of just cancel each other out. But they cancel each other out, but what do I have to do with that top limit? What would you do if there was an x squared there? Do you remember? So you'd plug in x squared, but then you'd have to multiply by the derivative of x squared. So there's a chain rule thing going on here. So dH dt. Which makes sense because they gave me dH dt. So I need to find f of 5 times dH dt. Oh, but they told me dH dt. So f of 5 times 0.26. Okay, f of 5 is y1 at 5. Again, your calculator knows that kind of notation. So y1 at 5 times 0.26. Correct, and they told me what f of h is, so I don't have to say what that is. They gave me that, so I don't have to keep writing that. I can just say f of h. So 1.694. Thank you. Units of measure again. F of 5 was, that's the area. F of 5 times dH dt. That's what we did. So area would be feet squared. dH dt is feet per minute. So if I multiply those two together, I get feet cubed per minute. Oh, well that makes, I could have done that initially. dV dt has got to be feet cubed per minute. Change in volume over change in time. feet cubed per minute. So you can do it kind of the long way like I did initially, and then I should have realized that the short way would just be volume is feet cubed, time is minutes. All right, that's a great example of an AP question, obviously, because it is an AP question. Trying to think what the point spread would be on those, because it always adds up to 9. Probably 2 there. So I would guess 2, 2, 2, 3. That would add up to 9. So you should definitely get all of part A. I'm just looking at what I think you should get. So there's 2 points. Hopefully you get part B, over estimate and the reason. That's 2 more points. C and D are a little trickier, but even if you only got A and B, you'd have 4 out of 9. That's 44%. That puts you on track for a 3. So, I mean, hopefully you get a few more points in the rest of the problem. But this illustrates that you don't have to be perfect to make a 3. I mean, you don't even have to be perfect to make a 5. So, when you hit some crazy stuff, do your best, but don't worry about it. Like if you get all the straightforward stuff, you make a 3. Get a little bit of the harder stuff, you make a 4. Get a little bit more of the harder stuff, you make a 5. Number 15. That took almost exactly 15 minutes, including the explanation. So, let R be the region enclosed by the graphs of y equals e to the x, y equals x minus 1 squared, and the line x equals 1. Okay, I kind of know what those look like. Like separately, I sort of know what e to the x looks like. And x minus 1 squared would be a parabola shifted to the right one. But like trying to know where their overlap is, I don't know about that. So I'm going to graph them. E to the x, x minus 1 all squared. Look at the graph. There's e to the x. My scale's not very good here, but that's okay. There's x squared. And the line x equals 1. Okay, so they're... Let's see, so... 1 and 1. There's my parabola. My... Let's see. At x equals 1... e to the first should be 2.7, so up there somewhere. So e to the x, x minus 1 squared, and x equals 1. So this is the area we're talking about. First question, find the area of R. Okay. Well, that's just top minus bottom from left to right. So from 0 to 1, the top function is y1, the bottom function is y2. So as long as I label them y1 and y2, I can use that as part of my answer. And I can just go to the calculator and type that in. Math 9, 0 to 1. y1 minus y2 dx. 1.385. Okay, so that's the area of that thing. I'm going to say that seems reasonable because the width is 1, the height is 3, but it's not all filled in, so yeah, that seems reasonable. Find the volume of the solid when R is revolved around the x-axis. Okay, so we're revolving around the x-axis. All right, discs or washers? Bo, is this going to be discs or washers? Washers, because there's going to be a hole there. So washers, is it dx or dy if we rotate around the x-axis? Really? It's going to be dx because my slices are going to be x slices. Sideways volcano looking kind of thing. So washers dx. So pi times big R squared minus little r squared. X limits, so 0 to 1, that's easy. Big R, okay, from the axis to the outer edge. From the axis to the outer edge. So top minus bottom. The top would be this curve, which is e to the x. And I'm good with e to the x because we want it in terms of x. The bottom is 0, so just e to the x minus 0. Little r, from axis to the inside edge. Top minus bottom. The inside edge is that parabola. X minus 1 squared, and the bottom is again 0. So really that's enough to go to the calculator because I've explained everything. I would probably write it one more step here. E to the x squared minus x minus 1 squared dx. So let's be careful with the calculator here. Parentheses. Don't forget the pi. F9, 0 to 1. I'm going to go parentheses. Or you could do algebra on your own. You could just say that's e to the 2x and save the trouble of, where do the parentheses go? E to the x squared minus the parentheses are going to mess me up on this one, so I'm just going to go x minus 1 to the 4th. Right? Otherwise I've got parentheses, parentheses, parentheses trying to get everything right. But if I'll just do the power to a power I multiply, I think that's easier than trying to keep up with parentheses. .408. And then lastly, set up but do not integrate an integral expression in terms of a single variable for the volume of the solid generated about the y-axis. Oh, yuck. Because there's the y-axis. So that's going to be dx or dy? dy. Disk or washers? Yes. And then what is weird about this problem? Well, maybe don't see it yet. So washers is r squared minus r squared dy. So that goes 0 to e, sort of. I should hold off on that. When it comes to outside r minus inside r, yeah, let's just start it and run into the problem when we get there. So big R is outside minus inside, or right minus left. So what's big R all the way down? Too many pictures going on there. Big R is from 0 to 1. So big R is always just 1. Like the outside of that thing is always radius 1. The outside of it looks like a cylinder. little r right minus left. Oh, here's the trouble. Little r changes because up top, on the top part, little r is, what's that, e to the x, but I'm not allowed to use e to the x, so that would be natural log of y. On the bottom part, little r is x minus 1 squared, but again, I'm not allowed to use that. Got to clean that up. So square root of y equals x plus x minus 1. So square root of y plus 1. Yuck. And that change happens at 1. That's where they intersect right there. So now I've got to integrate. I've got to split this into two pieces. From 0 to 1 is one set of things, and then from 1 to e, it's another set. So 0 to 1, big R is always 1. Little r on the bottom part is is square root of y plus 1. And then the top part, from 1 to e, big R is still 1. Little r is natural log of y. And that's why it said set up but do not solve, because take too long to type all that in. Alright, here's just my guess. 2 points, 3 points, 4 points, maybe. It always adds up to 9. Surely you get the 2. Hopefully you get the 3. Now 4, for part C, there's a lot going on there, but if you showed some work, maybe you recognize that it was dy, maybe that you recognize r squared minus r squared, so maybe you get 1 out of the 4. So let's say you get 5 out of 9. If you get 5 out of the 9 on everything, you're going to make a 4, maybe a 5. Probably a 4. So again, try your best on the hard stuff. Knock out the easy stuff. There's going to be crazy stuff. Hopefully you get a few points out of there.
Do you get partial credit if they have like the setup right, but type it on the
So it depends exactly how the grading, they give us grading rubrics so we know exactly what we're looking for. This is usually like 1 point for the setup and 1 point for the answer. So if you had all of this, it's probably 1 for the answer, because you got to get that. But it's probably, it would probably be 1 for the integrand and 1 for the limits. A lot of times they split it up like that. So yeah, if you type something in wrong, you might get 2 out of 3 there. Again, try your best on May 13th. Keep remembering that you don't have to be perfect to make a 5. You got to be good, but you don't have to be perfect.